Hello friends, welcome back to our channel Mirror Neuron, which means watch and learn. And today we are going to discuss a very common interview question which you will get during an interview. And the question is, so you all know about logistic regression, right? And you also must be quite familiar with the loss function of logistic regression. So there can be different types of loss function, applied during a logistic regression model. Okay, so the first loss function, typically given by the letter L. So suppose I have something as y predicted, and I have the original y value as well, right? So what would be the loss function? It can be the sum of squares, right? I can just take an average, and it can be y predicted minus the y original whole square, right? So this could be the one of the loss function. And the second loss function is given by bit looking cumbersome looking, but then it's not actually not. So it's again yp, because our main intention is to be able to find out the yp as correctly as possible, and it is given by the negative of the y predicted log of y original log of y predicted, right, minus I can convert that as plus, and then it says 1 minus y original given by log of y 1 minus y predicted, right? So you must be quite familiar with this too. Now the question in the interview typically is why we should not use this one and rather prefer to use this one. That is the main question here. So the answer you should be giving is, in particularly this one, what happens is the graph, is actually a, what do you call it, not a convex function, which means that there are many local minima here, and it will take a lot of time for the gradient descent to figure it out, and in certain point it will not even able to calculate or do that gradient descent because there are so many local minimum here. So typically, we look for a loss function which is convex. That means something which looks like this. So we know that there is definitely a global minimum, and here there are so many local minimum that it's very hard to find the global minimum, right? So that is the first reason. So that is why when we use this particular loss function, what happens is, say for example, let me just move the camera a bit. Yeah, okay. So what happens is, see, if my original y naught is, okay, sorry about that. So if my y naught is actually, or y naught is basically the y original, if it is the original value is 1, right, then I would expect my loss function, right, to be equal to minus log of y predicted, right? And in this case, why it is, when it is 1, then we know that this portion here will be 0, right? 1 minus 1 is 0, so this term cancels out, so we are left with this term, and that is minus y log of y predicted. And here in this case we want yp to be as high as possible so that it becomes somewhat close to log 1, and then it will be 0, right? Why it will be close to 1? Because we are doing logistic regression, and that's where the concept of sigmoid comes into picture, because your y predicted will be a value somewhere between 0 and 1. So the maximum value that it can take is 1, right? So that is why minus log of 1 will be close to 0. So we basically want this value to be as high as possible. So you see here, for my first condition, this loss function works really good. What about the second condition? What if y original is actually 0? So what my loss function is supposed to do, y0. So in this case, this term goes to 0, right? And this term stays in there. So my value is basically, so y naught is 0, so it will be 1 times log of 1 minus yp. Again, in this case we want this yp to be as small as possible, right? So that in that case it will be log of y hat is as small as possible, so that this eventually also becomes 0. The loss function becomes 0. So that is the reason why we prefer to use this particular loss function and not this one, because in this particular case we can find a solution quickly compared to this one. All right, I hope you have got the way how typically these questions are asked and how we are supposed to answer during an interview. So make sure you prepare your answer in a similar fashion. All right, so I hope you have learned something new today. So please don't forget to subscribe our channel, and we really put a lot of effort to bring new and important concepts and content for you. All right, you take care.